Hello and welcome to the solutions video for our April 7th assessments. So these are all the available assessment questions for our April 7th, 2025. Wow. Okay. So we see our assessment categories here, so you'll be able to skip ahead as we're going through. I'm hoping to start figuring out how to use the timestamps on YouTube so that we can flag it, or at least in the description, so that you know where to jump to. But we'll start with our questions for algebra and number 1. So the number 504 can undergo prime factorization, and we want to figure out what it factors to. So 504, we can always start with the lowest prime factor we can confirm. In this case, it's 2. 504 divided by 2 is 252, still even. So that factors to 126, still even. And we get to 63. So we have 1, 2, 3 2s. We keep going from here. 3 is the next smallest prime factor. Gets us to 3 and 21. It's still a multiple of 3. Leaves us with 7. So there we have 3 2s, 2 3s, and a 7. These are all prime. So this is 2 cubed, 3 squared, times 7 to the 1. So in the format we need here, that's 2 3 3 2 7 1. Now our next, express the following entire radicals as mixed radicals, where we have a root b. And we want to just write a and b adjacent here, figure out what they both are. Well, the only prime, or the only square factor of 45 is 9. So if we're not sure, just coming back here and switching colors, 45 we can see as a multiple of 5. It's also a multiple of 9, and 9 is a perfect square. We could check it. Is it a multiple of 4? Is it a multiple of 9? Is it a multiple of 16? And those are really the only 3 viable options, because it's not going to be a multiple of 25 or anything like that. Once we pass the number that's the square root of 45, which would be 6 and change, 49 is 7 squared, we'd have hit all the possible factors. Anyway. So if 45 is the same as 5 times 9 under our root, that's root 5 times the square root of 9. The square root of 9 is 3, so we have a 3 root 5. So then the answer as we record it is 35. Now here we're writing the mixed radical as an entire radical. We just want to write the radicand, being the number under this. It's a cube root, so we have to cube the 2 to put it in. 2 cubed is 8. 8 times 7 is 56. Lots of boxes here. You always have room to make all the common mistakes. One of which is cubing the 7 as well. Hence all the digits. Plus those numbers are randomized. So anyway, the least common multiple of 6 and 18. The smallest number, that's a multiple of both. Our calculators can do this for us if you've got the proper graphing calculator for the course. Regardless, it is 18 because 18 is a multiple of 6. Okay. So now, the greatest common factor of these. Well, 39 is 3 times 13. 169 is not a multiple of 3. If you add up 1 and 6 and 9, you get a number that's 1 more than a multiple of 3. Which means 13 is our only viable option. 169 is 13 squared. And 117 is 13 times 9. Again, we could actually just use the direct greatest common factor feature in our calculators for this. Okay, continuing with AN2 questions. So which of the following numbers is irrational? Now, we know this one is, but is this a check all that applies? If we try, we see we can check more than one. So let's check this on our calculator. If we take the square root of 12.25, well, yeah, that would be a 3.5. Decimals are allowed because you have a decimal here. This one is irrational. We don't have an exact repeating pattern. Now this one, 3 squared, this under the square root, if you think ahead to an4 and an5, multiplying and factoring polynomials, this fits the square of the perfect binomial pattern. So if we had a 3.0 plus 3.5 squared, it would fit this pattern. Why you do it without just doing a 6.5 squared, I'm not sure. But this does work out to 6.5. And this one, 42.875. There's no ellipsis, no dots after that saying it's continuing. That terminates, so that is rational. Now here, which of the given numbers are irrational? Well, 0.64, if we take the square root of that, we get 0.8. So that's a rational number. So that is present in 3 of our options. That automatically narrows it down to C. We'll go through the logic on the rest. For written response, 3 is not a perfect square. This one, the 6.4. Yes, 64 is a perfect square, but in order to have it work with the decimal, when you take the square root, you have to have an even number of zeros after the 4 or an even number of decimal places if it starts after the decimal. So 0.64 has 2 digits. You take the square root of that, you get 0.8. 6.4, you'd get 8 and then the square root of 0.3. That does not work. So 6.4 is irrational. And the square root of 9 over 16, 9 is a perfect square, 16 is a perfect square. The square root of that is 3 over 4. Now, 4 statements about numbers are given. Which of these given statements is true? Now, we could have asked which is false, considering these are all sets of 3 statements, and they are all, so they're all just missing 1. But we'll run through it anyway. The set of rational numbers is a subset of the set of real numbers. We covered the term subset. That means every rational number is real, but there could be real numbers which are not rational. That is true. Every rational number is a real number. The set of real numbers contains the set of irrational numbers. Yes, it does. Every irrational number is also real. The set of integers contains the set of whole numbers. Yes, the whole numbers are 0, 1, 2, 3, 4. They are all within the integers. So 1, 2, and 3 are true. Process of elimination says 4 is the false one. The set of rational numbers is a subset of the whole numbers. No, there are rational numbers which are not whole. 1/2 is rational, 1/2 is not whole. So, to which sets of numbers does 8110016 belong? Select all that apply. It is a natural number. That's 1, 2, 3, 4, and so forth. Everything that is a natural number, because the naturals are a subset of them, the naturals are a subset of the wholes. That's 0 and the naturals. The wholes are a subset of the integers, so it has to be those. The integers are a subset of the rationals. It has to be those. No number is both rational and irrational. So if you have it in one, it cannot be in the other. So therefore, for full credit on this question, you have to have all 4 of these checked. That one does allow partial credit if you only check some. So to which sets of numbers does this belong? So we don't see any clear repetitions here. Therefore, it is not a repeating decimal. It cannot be terminating because we have the ... On your calculator, it doesn't show the ... You just have to see that string. But that's not a definitive answer. I could give you 1 over 23, and you wouldn't see repeats on your calculator display, but it would still be a rational number. So you have to really think about the context of the question. All right, moving on to algebra and number 3 about exponent rules. we want to simplify the following exponential expressions fully with positive exponents only. So let's recopy these and do them on the whiteboard. So our first one, we have 4x cubed y to the negative 2 in the first set of brackets. 4x cubed y to the negative 2. Our second set of brackets is x to the 4th y cubed. And in the denominator, we have a negative 2x cubed y squared. But that is all within these brackets. Okay, so in the end, unless we can explicitly show that they cancel, we're going to have a constant, we're going to have some value of x, and we're going to have some value of y. So to make sure that your answer is complete, we have to look for those three elements. So the numerator have no exponents outside the brackets, so we'll combine these exponents across. The denominator will have to square each individually. So we start with a 4, it's our only constant. X cubed times x to the 4th. We add those, gives us x to the 7. Y to the negative 2 times y cubed is y, and I'm going to explicitly write the 1 for the intermediate step, even though it's optional. When we're squaring it, we could treat each of these as an individual square. A negative times a negative is a positive. So negative 2 squared is 4. X cubed squared is x to the 6th. Y squared squared is y to the 4th. All right. So our constant, we can explicitly show cancellation. So we do not have a constant there. Our x's, 7 minus 6 is 1. And then we have a 1 over 4. That's in a y to the negative 3, or y cubed in our denominator. So A should be x over y cubed. And yes, I do tend to use the keyboard commands, but we do have the fraction options on the menu, as well as the subscript and superscript. You could pick exponents, subscripts, and whatnot. But there's our simplified version of A. Okay. Now B, 3x to the negative 2 over 9y to the negative 4. So 3x to the negative 2 over 9 y to the negative 4. And that's, okay, a negative 4 over 2. Well, I'm just going to simplify that to a negative 2 right off the bat. That's what our 4 over 2 simplifies to. Inside, a 3 over 9 becomes a 3 in the denominator. Y to the negative 4 becomes a y to the positive 4 in the numerator. X to the negative 2 in the numerator becomes x to a positive 2 in the denominator. We still have that negative 2. Now we apply the negative 2. That's going to take our numerator, flip it to the denominator, and vice versa. So now, when we square it, we're going to have a 9. And then this is squared, so it's now x to the 4th. And y to the 4th squared is y to the 8. So there we go. 9x to the 4th, y to the 8. Now, I don't require you to use the actual... You don't have to use the equation editor. You can just write it like this with your Shift-6 caret for the exponents. I personally do like to have it nicely written out. The keyboard commands are modeled on the same LaTeX software I use to write our notes, so I'm very familiar with what those are. Okay. We have that one. We move on to our next written response, simplifying these with positive exponents. I think A I'm just going to write directly here because there's nothing simplifying inside that bracket aside from taking the square root of everything because we have that 1/2 outside. So square root of 81 is 9. Square root of x to the 4 is x squared. Square root of y squared is y. So there's A and B. Anything to the 0 is 1. So that entire first bracket is just plain gone. So now n to the 4 all to the -2 is n to the -8. Well, if we have a negative, but we're asked for positive exponents, means we have to write it in the denominator. So now, the value of the following expression is, we can put this right in our calculator if we want to. We can also recognize that 49 to the half is the square root of 49, that's 7, and that this entire bracket is to the 0, making it 1. 7 plus 1 is 8. So that's it for AN3. All right, that wraps up AN3. Nobody asked for AN4, so now we have AN5. 1 factored x squared minus 9 can be written as, well, we have a square minus a perfect square. That's the difference of perfect squares. So it's the square root of the first plus or minus square root of the second. X minus 3 times x plus 3. Now here we want to write the factored form of this equation. And our 16x squared, that's a perfect square. 9y squared is also a perfect square. So this is our difference of perfect squares. We can click the bracket button. Or we can just, if we hit the bracket on our keyboard, the brackets are automatically put into match. So here's our first. Now this factored form is going to be a little more complicated. I suppose I should not have flipped them to written response. We could take out the where A is smaller than C, because then I'm not going to be picky. The math itself is not picky. This used to be a numeric response. I should have deleted that caveat. Anyway, 21x squared is 31xy and 4y squared. So this one doesn't fit our patterns. 21x squared plus 31xy, and I think it was a 4y squared. Yes. So the factors of 21, it's either 1 times 21 or 3 times 7. And 4 is either 1 and 4 or 2 and 2. So this means we either have, right, x, all of our signs are positive. The positive here, it should be a y squared clearly. The positive before the 4 says that we have the same signs in both brackets. The middle being positive says they're both plus signs. So there are a few possibilities to check. If we have x and 21, then we either have a 4 and a 1, the x plus y, and 21x. Sorry, this is a web-based whiteboard. If I write too quickly, then it doesn't always catch all the details in the lines. These are the 4 possibilities. If we multiply these out, they will all produce our 21x squared, or they will all produce our 4y squared. But do they produce the 31xy? This one would give us 84 plus 1. So 85xy is not what we want. That one's ruled out. This one would give us 21 plus 4, that's 31. Or sorry, 21 plus 4 is 25, which is not 31. That one's ruled out. Here, 42 plus 2 is 43. That one is ruled out. That's all the possibilities with the 121. So now there's 3 more possibilities to check. We either have 3x plus y, 7x plus 4y, or 3x plus 4y, 7x plus y, or 3x plus 2y, 7x plus 2y. Now, for efficiency, I do recommend starting with things closer to the square root. So the 3, 7 is more likely to work out than the 121. If we look at the one with 2 and 2, the bottom one, our cross term would be 14 plus 6, which is 20. It's not that one. 7 plus 12 is 19. So it is this one, if it's going to work at all. Not all of these works. We do have to verify. 28 plus 3, that is our 31. So that's it. 3x plus 4y, 7x plus y. Oh, so 3x plus 4y and 7x plus y is the version that works. Our next one, write the factored form here. Okay, so we need factors of 52 and factors of 2. So 52 is 4 times 13. If we do 4 times 2, that's 8. 8 plus 13 will give us our 21. So when we're filling this one out, again, everything is positive. I'm going to come back. I haven't finalized our coefficients here. So we need our coefficients of y. We know we just said we're going to have a 4 and a 13. So we need 8 plus 13. That means the 13 cannot be multiplying the 2. The 4 has to multiply with the 2. So the 2 and the 4 have to be in different brackets because you can't multiply terms in the same bracket. So 2 times 4 is 8. 13 times 1 is 13. That's 21. And our fourth one, this is the product of perfect squares. Give me a perfect squares at the start and the finish. We're not just subtracting them, we have a term in the middle. So this is our a plus b all squared pattern. In the real world, it's not guaranteed to be there. On a test that's trying to test everything for this, when that's an element, it's a good thing to keep an eye out for. Square root of 9 is 3. Square root of 4 is 2. 3 times 2 is 6. You double that, you do get 12. So this is our product of perfect squares. If you don't see that and you do it out by hand, you will still get the same result of that 3x plus 2y, and the whole thing is squared. So that wraps up AN5. So continuing on. No one asked for RF1, so now we have relations and functions 2, which is a function which is a relation. And for each of these, is it a function or a relation? Here it's simple enough. A is a function because it passes the vertical line test. B, not a function. It fails the vertical line test. If you draw a vertical line through it in a lot of places, it will intersect twice. Here it will only intersect once. C, it actually fails the vertical line test at -3. At that point, -3. At that point we have there's 2 points at that point on the x-axis. And circles, classic example of something that's not a function, because again, it fails the vertical line test pretty much everywhere. going on to our next. Define both a function and a relation. Relation I'll define first. So a relation is a rule to map one set of numbers or elements. These are not always numbers. That's our domain. Onto another set. That's our range. So it takes an x and turns it into a y. A function is a specific type of relation where one input, or I should say where each input, that's a little more clear that it's all of them. Each input produces no more than one output. So a function is that type of relation where each input produces one output. When you graph it, that means it'll pass the vertical line test. All right. So, which of the above are linear relations? We need to select all that apply. Oh, here we got the number one instead of the Roman numeral one. I somehow missed that. All right, so if we have a linear relation, that means any 2 points, connect any 2 points, will have the same slope or the same difference between them in a linear function when you write it in y equals mx plus b form. So, relation 1. The x's always go up by 3. The y's always go up by 2. So 1 is a function. Not surprising considering it's an option every single time. Relation 2. Or sorry, it is linear, I should say. But we could have told that from these. So here, from -4 to -2, x has gone up by 2. -8 to -5, y has gone up by 3. So the next one, -2 to +2, it's gone up by 4. And our y goes up by 6. Here, x goes up by 4, y goes up by 6. 2 is a linear relation. So that gets us down to A and D, because 1 and 2 both fit. That means we can eliminate 3, because it's not an option in either of them. We can also eliminate it because that cube on x means it's cubic. It's not linear. Relation 4, is it linear? Yes, we multiply the whole thing by 2, and now we have an equation in our general or standard form. So 4 will also be linear. You could isolate it and write it in y equals mx plus b form to convince yourself, but it does work. Now, which of these are functions? Okay, so number 1, it's got a different x value every time, different input every time. That's a function. 2, it's a linear relation that is not a vertical line. That's a function. 3, no, this fails the vertical line test everywhere above x equals 0. 4, on the left, those are the points in our domain. There's only one arrow coming out of each of them. So the fact that 2 of them are pointing to y equals 6 doesn't matter. That is a function. And yes, so it is a function, not a linear one, but it's a function. Okay, moving along to relations and functions 3. So we use these points to answer the next question. First, we have to graph the line. So 0, 10, we'd be putting a point right here. Maybe with a highlighter, would that work better? So we've got a point there. 3, 7, there's a point there. 10, 0, there's a point there. So if we do this one, we don't need to pen details. We can draw, ideally with a ruler. If you didn't bring one, side of your calculator works well. But yes, we can draw what should be a straight line connecting those two. Just going to go annotation off. The automatic scoring requires me to put something in there to give it a mark. So I'm just going to say, see annotations. Now find the slope of the line. Well, if we look at our first and last points, the change in y is negative 10, the change in x is positive 10. Negative 10 over 10 is a negative 1. Now the graph, y equals negative 3 minus 4, passes through which of these points? Well, that negative 4 tells us the y-intercept is minus 4, so that gives us point A. Slope of 3 over 2 means it rises 3 and goes up 2. So 1, 2, 3 over 2, boom, boom. That means we include point S. There we go. Now from S, we go up 1, 2, 3, and right 2. We are off the graph. We don't have to worry about the middle ones because 3 halves, that would be on the half line. There'd be 1 point here, 1 point here. We don't have any points there to label. So those are the 2 points on the line. Now the slope of a line passing through negative 3, 7, and 2, 7 is, our y is the same in each case. So our change in y is 0, our change in x is 5. 0 over 5 is 0. All right, that's relations and functions 3. Moving on to relations and functions 4. So what is the slope of this line? Well, we have a 2 before the y. So we have to divide everything by 2 to get it into y equals mx plus b form. Slope is the coefficient of x after we do that. So the slope is 4. And the y-intercept is negative 7. So which of the following table of values represents h equals 12 plus 3b? So that means when b is 0, h is 12. So a is a possibility. B is eliminated. We don't have them here. When b is 1, h is 15. A is still possible. C is eliminated. D is eliminated. So here we go. We start at 12, go up 3 each time. So what table of values is represented by this graph? This is the y equals x line. X and y are always going to be the same. That looks like it was A here as well. Finally, complete this table of values. X consistently goes up by 2. Y consistently goes up by 4. If we want to be super fancy, we can put our own table in. So we have a y, an x here, a y here. We can center justify everything. Which seems to be a little slow. Actually, it seems to be quite slow right now. I should probably close some of these apps that are using gigabytes of memory. In any event, going up by 4, we'll have 13 and 17. We close some of these tabs. I'll leave Desmos open in case we need it. Possibly GeoGebra. And wait for Firefox to respond. Okay, relations and functions 5. We're looking for the domain and range. Empty dots. These are not included in the graph. The domain is what x values are allowed. Okay, and this still seems to be slow to write. Annotation is off. So here our x is greater than negative 2. It is not equal. It's not greater than or equal to, because then that dot would be filled in. And our range is greater than negative 3. Okay, I have close some extra tabs and apps. Hopefully that picks up the performance we need. So we've established x is greater than 2, y is greater than 3. Now, in our next question, it's a very similar idea. We have that open circle, so we need greater than, not greater than or equal to. That eliminates A and D, or A and C, sorry. Now, x is greater than negative 2, y is greater than positive 2. That's our domain and range. And this is the set notation. Now, domain and range of this one. The arrows point off saying we're extending to infinity. It's still going a little bit left and a little bit right. So x is, remember, the real numbers. That narrows it down to one of the last two. Y has a lower limit before it comes up. Y is greater than or equal to negative 2. And now for this one, match the graph to the correct domain. So the first box is x greater than or equal to negative 3. So it has to start at negative 3 and never end. That's graph 3. Domain from negative 3 to positive 4. That's our ellipse in graph 2. The domain x is negative 3 and negative 3 only. That's our vertical line in box 1. Oh, I said 1 and typed 0. And process of elimination. Oh, no, you know what? I made a mistake. We have two that go from negative 3 to 4. I wasn't paying enough attention. Second box is strictly less than. Fourth box is less than or equal to. That's the difference between box 2 and 4. This is why when we're down to 1, we check it anyway. Had I just gone forward, I would have missed the mistake on 2 and introduced another mistake on 4. So even when you're confident, double check. All right, so now relations and functions 6. These are the other forms. So we want to express this equation, y equals negative 6 over 5 times x minus 3 in general form. So this is in slope-intercept form. Y equals negative 6 over 5x minus 3. Now, general form, no fractions. So we'll start by multiplying everything by 5. That cancels the fraction here. Or rather, it simplifies with it. This becomes a 30 over 5. And that is a 15. We also need a positive coefficient of x. So we can add 6x to both sides. We get 6x plus 5y is negative 15, or 6x plus 5y plus 15 equals 0. I will accept either of these forms. You can make an argument for putting the constant term on either side. So I will take both. So 6x plus 5y is a negative 15. Okay, and multiple choice 13. 3 statements about this line are given below. The line has a slope of 5. Well, let's check that. We see the 5 before the x, but it's 5x plus y. We have 5x plus y minus 1 equals 0. If we write it in our more familiar slope-intercept form, we see our slope is a negative 5, and our y-intercept is 1. So, what's true? Slope is 5. That is not true. Y-intercept of 1. That is true. So 1 is false and 2 is true. Kind of implies that 3 is going to be true by process of elimination. Had this been numeric response, where you're just filling in 1, 2, 3, we'd also have to explicitly check number 3. The point negative 3, 16 is on the line. Negative 3 times a negative 5 is a positive 15. Add 1, we get 16. Yes. It is a point on the line. All right. Negative 5 Slow because for some reason I'm using the mouse instead of the stylus. But slowing me down like that does make it neater. But yeah, that is our 16. So 1 and 3 are true. All right. So now we have two statements. We have to turn these into general form. We need to find the general form of the line passing through -3, 2 and 0, -4. All right. So one thing we could ask ourselves, what is the slope? When we gain 3 points in x, we lose 6 in y. That's a slope of -2. So our slope, change in y over change in x. Here we go from change in y. Let's say we do a -4 minus 2. And if we start with the -4 on top, we have to start with the 0 on the bottom. 0 minus -3. That's a -6 over 3. Our slope is -2. 0, -4 is the y-intercept. So our line is -2x minus 4. That's our slope-intercept form. General form, we bring our 2x across. 2x plus y is -4. So our x comes first with a positive coefficient. There are no fractions. The y is on the same side. Constant can go either side. So a is 2x plus y equals a -4. Okay, and now b, the general form of this one. So our general form of y equals 3/5 x minus 4. So y equals 3/5 x minus 4. Again, no denominators. Multiply everything by 5. We need a constant or a positive coefficient of x. So we can subtract the 5y from both sides. There are no y terms to combine with. So we have 3x minus 5y minus 20 equals 0. That is acceptable, as is the 3x minus 5y equals 20. If you don't have to move it across, you don't need to move it across. We should all be able to do that. Sometimes we get stressed and miss the sign change. So if you don't have to, then if you don't have to do a step, I would say don't do the step. So that's minus 20 equals 0. And now here, the slope point form equation of the line shown could be, our slope was positive 1, so that is one of our first two options. So either we have the point 1, 3 on the line or 3, 1. 1, 3 is on the line. That's B. Okay, moving on to RF7. The slope of two parallel lines are given by -3 over 7 and -48 over k. The value of k is, well, if these are parallel, the slopes are equal. So we have two approaches. One is to say, oh, 3 times 16 is 48, so 7 times 16 is going to give us k. Another one, if you don't immediately spot that, so possibly the more common way to solve it is to just explicitly equate them. -3 over 7 is -48 over k. We multiply by both denominators. We have a -3k here is a -48 times 7 over here, and divide both sides by -3. We still get the 16 times 7. Now 16 times 8 is 128, which is something a lot of computer nerds have run across enough it's memorized. So that would be 112. Okay. So K should be 112. Now, the slope point equation of a line passing through these points is, well, what's our slope? We have negative 17, negative 18, and 9, 5. Just writing those down for reference. Negative 17, negative 18, 9, 5. So our change in y divided by our change in x. We have a 23 over 26. So we are looking for that slope. That is A and B. So which of these is the point on the line? Well, that's the one that goes through negative 17, negative 18. The double negative, we're checking that we know from our form that it's y minus y1 and x minus x1. So if we have negatives already, those are going to flip to positives. All right, numeric response 13. These lines are perpendicular. The values of A and B respectively are. Well, let's take a look at how we can figure that out. Our first line, 2x minus 7y minus 6 equals 0. If we write this in y equals mx plus b form to see our slope, then starting by moving that, or adding 7y to both sides to subtract the negative 7y. We'd end up with a 7y that would normally be on the right, but we can write it on other sides, so I would just flip it around like this. Divide both sides by 7. So if it's perpendicular to this, then the slope of the other one is going to be a negative 7 over 2. So what is it in terms of A and B? We have AX plus BY. So AX plus BY minus 4 equals 0. So we'd have BY is a negative AX plus 4. So Y is going to be a negative A over BX plus 4 over B. Now, A and B cannot both be even. If they were, it wouldn't be in proper general form. So what we know is that negative A over B has to be equal to negative 7 over 2. So then A is 7 and B is 2. A little trick to speed this up in the future. We did it the long way. The way the algebra works out, when we're in general form, if you flip the coefficients, so 2, 7 becomes 7, 2, and then make sure that you change the sign on the y term, here it was negative, now it's positive, you will always get a perpendicular line. Okay, multiple choice 16. Given that the slope of a line is negative 3 over 5 and the y-intercept is 4, the equation in general form. That actually seems familiar. I think we had that same combination. Slope is 3 over 5. Here, oh, the y-intercept is a positive 4. Yeah, that's just going to change the sign of our constant. So we're going to have a 3x minus 5y, right? And instead of, yeah, there we go. Oh, sorry, the slope is a negative 3 over 5. That's why it seemed odd. This is a positive 3 over 5. The slope is a negative 3 over 5. That's why the coefficient or the sign on 20 seemed off. Now, algebraically determine the x-intercept of this. This says algebraically determine. With the tech limitations of our calculator, we need to do that. Had they given it to us another way, numeric response, multiple choice, they usually can't tell how you did it. Our x-intercept is when y equals 0. That gives us 6x equals 13. Divide by 6. So writing it out explicitly, going back down here. So it was 6x minus 2y equals 13. 6x minus 2y equals 13. We let y equal 0. And divide by 6. So our slope becomes 13 over 6. All right. So moving on to relations and functions 8. This is function notation. So f of x is 3x squared minus x plus 4. We need to find f of negative 3 first. So f of x is 3x squared minus x plus 4. So f of negative 3, it's in the bracket, so it's replacing x is 3 times negative 3 squared minus negative 3 plus 4. So that is 27 plus 3 plus 4. That is 34. And that's doing it by hand. Obviously, you could also take our first substitution step and put that in your calculator. So A, 34. For full marks, or when we're doing the partial marks, you can fill it in. Now B, we can't just plug that into our calculators. That's f of x minus 3. So for part B, this is the one worth 2 marks. That's why the whole question is out of 3. Wherever we see x, that was not what I wanted. We replace it with the entirety of x minus 3. So that's going to be 3x squared minus 6x plus 9 minus x plus 3 plus 4. Or just distributed the negative through the brackets and left nothing here. Now we'll distribute the 3 through the first bracket. 3x squared minus 18x plus 27 minus x, and I can combine these right away to a plus 7. Now, all of our multiplications are done. We just have to combine our like terms. Go exponent by exponent. We have 3x squared. Now for our regular x terms, we have a negative 19x from the negative 18x and then another negative 1. And 27 and 7 make 34. So that's 3x squared minus 19x plus 34. 3x squared minus 19x plus 34. Okay, so if f of x equals 3x minus 1 and f of x equals 8, then x equals, major emphasis here, it's giving us the value of y, not x. So it's giving us f of x equals 3x minus 1. Sorry, there we go. And the equivalent of y equals 8. And we need to find x. We're looking for that point of intersection. We could use this method on our graphing calculators. Put this in as y1 and y2. and plot the graphs and find the point of intersection at x equals 3, we could also say that our y value equals 3x minus 1. We add 1 to both sides, and then divide both sides by 3. Either approach gives us x equals 3. Because it's multiple choice, you could also take the approach of substitution. 3 times 7/3 is 7 minus 1 is 6. Eliminate A. 11 minus 1, eliminate B, and so forth. Now, given negative 2x squared minus x, what is the value of f of negative 4? Again, we are substituting negative 4 where the x goes. So negative 2 times 16 gives us a negative 32, plus 4, a negative 28. That's another one we can enter in our calculator pretty much exactly as is, provided we remember to put brackets around the negative 4. All right, RF9, Relations and Functions 9. So here we have the system of equations below. 2a plus 8b is 6. A plus 5b is 2. There are two equations with two unknowns. So 2, 8, and 6. You know what? If that 2, 8, and 6, notice how they all have a common factor of 2? I'm going to divide that whole thing by 2 right off the bat and simplify it. So a plus 4b is 3. And a plus 5b is 2. If we take the substitution approach, we could say below a is 2 minus 5b. So 2 minus 5b plus 4b is 3. 2 minus b is 3. Negative b is 1. B is negative 1. Elimination. We could subtract the first equation from the second. That gets us directly to b equals negative 1. We could also apply the logic of saying, hey, that second equation is just one more b than the first. So we add 1b and we lose 1 from the total. Either way, we've got a few approaches here, all of which have gotten us to b is negative 1. It's asked to express to 1 decimal. In a machine-scored question, we add that decimal even though it's 0. Because there are some picky machine scoring that will take negative 1 is wrong, but negative 1.0 is right. So we always add or put in the number of decimals they asked for. Now we just need to find a. Well, a plus negative 4 is 3. That's substituting negative 1 for b. Or a is 7. Does that make sense? So if a is 7, this would be 14 minus 8. That's 6. 7 minus 5 is 2. Yes, a is 7. Expressed to 1 decimal, that's 7.0. All right, so now sketch the graph of 3x minus y equals 3. And insert an image of your graph, or we're doing it in class, so we're writing it on paper. So when y is 0, x is 1. When x is 0, y is negative 3. So with a slope of 3, we're going to go up 1, 2, 3 over 1. 1, 2, 3 over 1. Oh, I think we just found our point of intersection. Okay, sorry, that is not a very straight line. This is why we're doing these on paper even when we're there. Point is, right here, that is our point of intersection. Looks like x equals 3, y equals 6. Does that make sense? 9 minus 6 is 3. 6 plus 6 is 12. Yes, so 3, 6 is our solution. This graph, we see annotation, because yes, I can see the annotations on my end. Oh, and we already did the verification. So 2 times 3 plus 6 is 6 plus 6, which is 12. And our second one, 3x minus y. So 3x minus y. Yes. Is 9 minus 6. And that is 3. Yes, that checks out. The left-hand side equals the right-hand side. All right, starting measurement 1. The reference that best match each measurement are. So if we want 1 foot, or 1 yard, 1 millimeter, 1 mile, thickness of a quarter, that would be a good one for 1 millimeter. The length of your bent thumb, that would be more like a centimeter, possibly an inch. Distance jogged in 10 minutes. Well, that might be a mile. We can come back and change these if we find better ones. Length of a cell phone. Yeah, when I was in high school, a cell phone might be a foot long. That's not the case anymore. The length of a car. That's too big for a yard, too small for a mile. Length of this test. That would probably be closer to a foot. We printed on 8.5 by 11 inch paper, even though we're in Canada. We use the US standard paper sizes. That's close to a foot. It's 11/12 of a foot. And the height of a doorknob, that's usually about a yard off the floor. Classroom ceiling would be more like 2 to 2.5 yards, or maybe 3, depending on the school. All right. So what is the best referent for an inch? Okay, so that's more like the width of a quarter than the width of your hand. Too big. Height of a pop can is too big. Length of your foot is too big. So width of a quarter. Okay, so now, yes, we have a bunch of angles here, but this is not about trig. So 4 students made the following estimates regarding the measures of angle A in different pictures and came to the following conclusions. So A is between 0 and 90, since it's less than a right angle. Looks like about 3 angle A's could fit into a straight line. So angle A should be about 60. That's reasonable. You could also say angle A looks like it's about double this angle, and those two add up to 90. So if it's a 2-to-1 ratio, that would be that 60-30. So student 1 seems to be reasonable, and we're looking for the least reasonable angle. Student 2, angle A is between 0 and 60, since it's smaller than a third and 180. Probably smaller than 45, since a diagonal through a square would produce a 45. And it seems less than a diagonal. Okay, so this one seems reasonable, but less reasonable than 1. So right now, I would go with student 2. Angle A is approximately 120. It's definitely more than 90 and looks like 2/3 of a line. I would say that's more reasonable than 2. Right? They're looking at about a third of 180, smaller than a third of 180. We don't have that 180-degree line completely as reference. Here we do. So I think 3 is more reasonable than 2. Here, angle A is approximately 271 degrees since it's gone around more than 3/4 of a circle. Well, 271 would go from this starting point to a completely vertical line. This looks like it goes about half of that quadrant again. So I would say this is more like 315. So even 2 is a little bit shaky. It's definitely better than 4. 4 is the least suitable estimate. now we have a written response. Now there's two different situations. You can take your choice, indicate which one you want me to mark. So if you take a stab at both and then go, no, I feel more confident in B, you ask me to mark this one. But the width of the seat of your chair, well, this one we could look at, say, your belt size. For men, that's pretty much a one-to-one match with how many inches of material there are around your waist. For women, the sizes don't seem to be as standardized or make as much sense. But the width of the seat, we're probably at somewhere about the 30 centimeters. So the seat is often around 30 centimeters or a foot wide. Larry says that his bedroom is 4.5 wide. What units might Larry have used for this measurement? Well, explain why those units are reasonable. So we have to pick reasonable units. We can't say, oh, he used millimeters and he's an idiot. No, we want to pick something that's reasonable. 4.5 feet is too small. 4.5 meters or 4.5 yards might work. We don't want to go to kilometers. So I'm going to say for part B, I would accept either meters or yards for that. 4.5 of those across is reasonable for the size of a room. All right. Now, which equation cannot be used to convert 5 centimeters to inches? We have our conversion that 1 inch is 2.54 centimeters. So we want to do 5 centimeters into inches. We would expect something a little less than 2. 5 centimeters to inches should be a little more than 2. Or no, slightly less than 2 was correct. We want 5 divided by the 2.54. So the first one works. If you are in doubt with a multiple choice question of this type, you could do all 4 of the calculations and see which one works to get there. So this is saying x are unknown. Is 5 out of 2.54. Here, our 5 centimeters is the unknown. That's the same as 5 over 2.54. So A, C, and D, 3 different ways to measure 5 over 2.54. B is the one that would give us the reciprocal. That's 2.54 over 5. So now, convert 2 pounds into ounces. We see here 2 pounds is 16 ounces. We're asked to round to the nearest hundredth. So, if they say hundredth, do the hundredth. Yeah, 1 pound is 16 ounces, so 2 pounds is 32. But if we have a machine-scored question specifying the number of decimal places and you use a different number, it may score a right answer wrong. Now, 3,330 kilograms into tons. That's 1,000 kilograms. So what we're doing there is moving the decimal. Each 1,000 kilograms is a ton. So we have a little over 3 of them. We stop at the 0.33. So now these conversion factors. Convert 18 Celsius to Fahrenheit. That is our first one. So we have the equations, 9 over 5 times 18, and then we add 32 to that answer. Calculator tells us 64.4, again, specifies hundredth, so we add the 0. Now 85 Fahrenheit to Celsius, we use our second one, 85 minus 32 times 5 divided by 9. We get a 29.4 repeating, which is 44 to the nearest hundredth. Moving on to measurement 3, one of the most popular ones. I think in the future I'm going to scan ahead to remind myself which are the most popular curricular outcomes and do the solutions in that order. So if most people do M3, then we'll start the test with, or the solutions video with M3 and jump around. Anyway, what is the surface area of a sphere with a circumference of 15 inches? So we have our formula sheet up at the top. That formula sheet will tell us that the area of a sphere is 4 pi r squared. So, changing colors. So the circumference is 2 pi r, and the area is 4 pi r squared. So, little trick here. Yes, we can say r is c over 2 pi, square that and multiply by the 4 pi and get the area. You might also notice that the area is circumference squared over pi. If you square the circumference, you get 4 pi squared r squared. Our circumference is 15, so we could take 15 squared divided by pi to the nearest square inch. On the calculator, that's a 71.6197, but we were asked for the nearest square inch. That's 72. All right, the volume of this 3D object, that's the area of the base times the perpendicular height divided by 3. Length is 8, width is 6, perpendicular height is 9. Divide that by 3. We divide by 3 because it's tapered to a point. Anything that tapers to a point, we divide by 3. That gives us a volume of 144. The surface area of the 3D object. Well, here we have 4 triangles that we need to deal with. So, 4 triangles on the rectangular base. Rectangular base is length times width. Now, let's say we do the back. So just to highlight here, the back is this triangle there. That'll be the same as the front. I'm not sure why that's not letting go now. Annotation off. But the back will be the same as the front, which is L this way and X up the front. So we have 2 triangles that are each 1/2 LX. And similarly, 2 triangles that are 1/2 WY. Now they did us a favor by providing us with the values of X and Y. They didn't need to. We have H, right? We have our L. So we could say y is the hypotenuse of a right triangle where one side is 1/2 L, the other side is H. So in any event, they gave them to us. So filling that in, our L is 8, and our W is 6. Our X is 9.49. Our Y is 9.89. I said 9, but I saw 5. Now this is something we could type into our calculator as is. I get 183.02. Would be an irrational number if we calculated X and Y on our own. Now here, the volume of this 3D object, this is a cylinder. So the volume is just pi r squared h. So pi, r is 11, and so is h this time. So it's just pi times 11 cubed. Pi times 1,331 to the nearest hundredth is 4,181.46. I've got 4598. We round it to 46. Surface area. That's 2 pi r squared plus 2 pi rh squared, and r, in this case they're both 11. So again, plug and play, that is 1520.53. And that should round up measurement 3. Okay, measurement 4, our last curricular outcome for this test. Angle A is 22 degrees, angle B is 78, side length B is 5.3. We need to find x. Well, we can actually do this as two triangles. Here's triangle number 1. So we can use the tan. B is opposite. This side down here would be the adjacent. So opposite over adjacent. The adjacent would be the opposite divided by the tan. So 5.3 divided by the tan of 78. Making sure we are in degree mode. That means this side down here is 1.1264977769, and more digits that don't fit on the calculator display. So we have that. Now let's pick a different highlighter. We also have enough information to use the tan on this triangle. This will give us the entire horizontal piece. X will be this entire side minus this bit. So this is still 5.3 as our opposite. Now we're dividing by the tan of 22, which gives us 13.117. And then we subtract the previous answer. Works out to 11.99141, or 12.0. From here, you are an ant on the grass, a distance of 80.7 meters from the base of a tree, of height 17.1. We want to find the angle to the nearest tenth of a degree. This is another tan question. The pen is better. Also mightier than the sword. So our tan theta is 17.1 over 80.7, but we're looking for the angle, so here we use the inverse tan of 17.1 divided by 80.7. And this angle is 11.963778889. It rounds to 12. All right, now we have a triangle to solve. So let's take a look here. Let's draw vertical line, horizontal line, and a diagonal line. This angle down here is given as 55 degrees, not radians or some other, and this one is 21 centimeters. This is a right angle. So, ideally, when we are solving a triangle, we're going to use the provided information for all of them. We could use the cosine to figure out this side over here, and then the Pythagorean theorem to get the opposite side. If we do that and we make a mistake to find the adjacent side, then our opposite side will also be wrong. So if we go back to the original information every time, we can do it. Now when you have two angles, the third angle is the easiest to get. It's 180 minus the other two. Now 180 minus 90 minus 55 is 35. That's our angle here. So we have distance, distance, the angle, 35 degrees. So now AC, our curve makes contact with that line. This is our adjacent. So the cosine should be an S, not an 8. The angle in this case, we have ABC. If we use our conventions of using the lowercase letters for the opposite sides, that's a lowercase c, which is sometimes hard to distinguish from capital C. But the cosine is adjacent over hypotenuse. That's B over A. So the adjacent side is A cos theta. So our hypotenuse is 21 centimeters times the cosine of 55 degrees. 21 cos 55 is 12.045105 yada yada yada. So that's distance AC, nearest tenth of a centimeter, 12.0. AB is going to be almost identical logic to say that it is, actually, yeah, it's going to be A sine theta. It's the opposite over the hypotenuse. So then the angle, or the opposite side, will be the hypotenuse times the trig function. So that is 21 centimeters times the sine of 55 degrees. And that works out to the nearest tenth, 17.2 centimeters. All right, we are finally there. We have the ability to submit. All right, I've now verified the answer key that was working for everything. I do have to apologize to those of you who are doing RF2 in this assessment. I somehow neglected to actually tag the questions as RF2. So there are 5 marks here. 3 of those are written response, 2 of those are numeric response. The numbers will show in your total at the top, but they won't show in smarter marks down here. That's my mistake. When you see it on the Google Classroom and PowerSchool, as well as on your spreadsheets, those numbers will be correct. But that's the solutions to this assessment.